Good afternoon to the professors and my dear friends. Myself Buddhadev Sahu. I want to present my recently accepted paper in OTCon 2021. This is sponsored by IEEE and this section belongs to IEEE Kolkata section and IEEE Bhubaneswar section. My topic title is Modifier Least Mean Square Technique for Harmonic Elimination. My paper ID is 48. And to accomplish my study, the study contains objective introduction, 4 lectures, active filter, power filter, robust controller design, system results, harmonic analysis, comparative study, conclusion, future study, and references. Before we are going to the subject, the objective of the study is looking at the real-time system. First major objective, the proper design of 3-phase 4-wire system. The necessity of 3-phase 4-wire system is to regulate the neutral current by which the circulating current is regulated for improving the power quality and reliability. The second major objective for majorly focus on the design of the inverter and controller strategy, and the third is for improving the stability. Third major objective of the paper is to regulate the receiving voltage of the shunt active filter at its desired value and compute the reduced switch current error through an adaptive step size selection. As per the planning, the appropriate design of reduced switch voltage source inverter and control strategy not only enhances the power quality and stability but also decreases the system cost, size, and complexity of the system. In the introduction section, we are doing some literature survey, and initially after doing some literature survey we found that nonlinear and sensitive load application for is gaining interest in real-time system applications, and during the real-time system application it decreases the power quality. Therefore there is a necessity to properly develop the inverter and control strategy for better performances. Then regarding the inverter, we do some literature survey. We found that active power filter and passive power filters are designed by the researcher to compensate the harmonics. Previously passive filters are widely used due to the simplicity in nature. However, the performance is decreased due to the excess larger size, static mitigation, resonance, and source impedance. To overcome the problem, shunt active power filters are designed, but however the performance of the shunt active filter is decreased due to the negligence of neutral current component. Therefore, as a solution, it is necessary to properly develop a shunt active filter by considering the neutral current. And after the development of the shunt active filter, we specifically focus on the controller part, and after doing some literature survey in paper number 13, a repeated control approach is suggested to compensate the harmonic load, and however during the perturbation period it takes more time or compensate the harmonics. In paper number 14, similar application is occurred by using robust controller, but here the researchers are not considered the sensitive and nonlinear load applications. In paper number 15, mathematical morphology and instantaneous theory based controller is developed for larger power application. However, the control design is difficult. It produces an additional computational burden to the system. In papers number 16 to 18, researchers are specifically focused on the multi-level inverter design by using the PI regulator, but however they are using excess switches for designing the multi-level inverter and also decreases performance. Looking at the above problems, we are formulated the major contribution of the study, that is a 3-phase diode bridge nonlinear load is model, reduced switch 4-leg shunt active filter is model and integrated in a 3-phase 4-wire system. Modify least mean square MLMS technique based shunt active filter is also proposed for selective harmonic elimination for better power quality. A MLMS technique is applied to separate the positive and negative sequence component. To show the PQ improvement by considering the harmonic percentage of the grid, current and voltage, a comparative section is also presented at last of the section. And this is my complete system design, where a source is directly connected to the unbalanced load, and unbalanced load is generated some harmonics into the system, and by using my proposed inverter, this is control the harmonic is regulated. And to control the harmonics by initially conventional least mean square algorithm is suggested, and here we are using a load current, and load current is continuously filtered by using the filtering technique, and it generates some error. By using this error, by further comparing this error to the appropriate actual nonlinear load, we are generating another error, or this is the error is minimum here en, and after this is a continuous closed loop cycle. By using this method we are generating computing the error method. However, in the conventional List means square the adaptive step size selection. There is a in numerator we are taking a constant value, but the denominator this is a time dependent value. But when the time dependent value there is a problem occurred, the computation technique takes more time during the variation of the nonlinear load, or at the variation instance of the nonlinear load there is a problem occurred. To circumvent this problem, the modifier list means square algorithm is proposed, and during the proposed modifier list algorithm we are adding a additional theta value. This is additional theta value, and the adaptive size of the adaptive step size of the system is totally time dependent value. There is no constant value is requiring. This is totally time dependent value, and we are modified the weight function also. Then highlight of the proposed approach is directly proportional to the output response. During the starting condition, the compared output is initially maximum, but later on this is decreased by compare, and during this the convergence speed of the controller is increases significantly, and this is my total highlights of the study, and this is my complete control structure. Initially we are using the nonlinear load current and source voltage for calculating the u alpha and beta component. From the alpha and beta component, the proposed MLMS technique generates some lesser error, and further it is compared to generate the actual error component, by which we are generating some inverter pulses, accurate inverter pulses for the inverter operation, and compute the harmonic current. And the later on the result analysis section, initially we are integrating nonlinear load based systems applications, and here this is the voltage and current results. This is showing that the system voltage and current waveforms are nonlinear in nature, and by using my proposed controller, this is my inverter voltage, and it is shown computed that the TSD value of the load current is computed that is 13.6, which is quite high, and by using the conventional method the TSD is reduced to 2.18%. but however by using my proposed approach, the TSD of the system is reduced to 0.62%. This is very lesser value, by which the system able to improve the performances. Further to analyze my system performance, by I am using a unbalanced load application. This is also used for unbalanced load application. Here the from the current result, it is clearly shown that this is an unbalanced current, and by using my proposed approach, the inverter is also capable to generate some unbalanced current, by which the source current is a linear. We are generating a linear source current, and after computing the TSD percentage, the source current percentage is also reduced. The source TSD percentage also reduced to 0.92%, and this is also very lesser value, and this clearly illustrates that the performance of the system is significantly improved. And this is the stability waveforms like body plot we are present here. By using this is the peak value of the total whole system, and this is the peak value of the DC link voltage, and it is clear that by using the conventional method, the peak value of the system is very high, and during the proposed method the peak value is very lesser, and this is clearly shows that my improvement or my controller improvement for the real-time applications. And at last, the conclusion and future scope: due to the simpler control and system modeling, the system complexity, size, cost, and computational burden of the system is decreases. The improved reference current extraction algorithm is successfully developed and implemented for harmonic filtering operations. The proposed MLMS based controller improves the power quality significantly, and it is verified from the above result analysis. The obtained and analyzed results serve as a basis for designing an appropriate system and controller for real-time applications. After gaining some advantages, the future scope of the study is reduced switch cascaded edge bridge multi-level inverters. It can be applied microgrid, hybrid microgrid, and hybrid vehicle operation. This controller can be applied, and fuzzy NNB and repetitive controller approaches can be used for DC link voltage control, and we can use the proposed controller. Therefore we can use the proposed controller for real-time application study, and this is my references, and thank you.